Citizen science has become an incredible resource for gathering and sifting large amounts of data that individual scientists just can't handle on their own, from documenting birds around the world, to sampling the human microbiome, to even transcribing century-old weather records. Now, reports Paul Rinkin at the BBC, citizen scientists have added another feather to their cap, combing through reams of data to identify a 5-planet system orbiting star K2138. Data comes from the planet-hunting Kepler Space Telescope. Launched in 2009, the NASA satellite completed its primary mission's search for exoplanets in November of 2012. On its hunt, Kepler would monitor the brightness of stars, and then scientists would pore through the data in search of winks in that light, the telltale sign of an orbiting planet. But after its initial mission, Kepler was struggling. By 2013, scientists had lost the ability to precisely direct the telescope's instruments, rendering its mission at an end. But engineers salvaged the telescope by designing a secondary mission dubbed K2. In the course of 3 years, that mission has gathered data on an additional 280,000 stars. The Kepler database is massive, and computers can't yet take on all the dirty work. As Calla Cofield at Space.com reports, while software is able to identify stars that host planets, it still takes a human to confirm the data. So scientists turn to citizen scientists for help, developing Exoplanet Explorers, hosted on the Zooniverse platform, a system that connects citizen scientists to projects. According to a press release, anyone can sign up for the site, and after a little training, users then look through signals and vote on which dip in brightness seem legit. If a minimum of 10 or more users agree with 90% certainty that a potential planetary transit is real, it goes to researchers for confirmation. The program was a success. In just first 48 hours since the project went live, more than 10,000 users chimed in with over 2 million classifications. That's where the new, and unusual, solar system comes in. Citizen scientists identified the 5-planet system in early April, just 2 weeks after Exoplanet Explorers launched. And astronomers quickly confirmed the system, finding it is extremely likely for the system to contain 4 planets, and possibly a 5th. There are still more hints it may even contain a 6th planet. All of the planets in this solar system are considered sub-Neptune planets, which are 1.3 and 3.3 times the radius of Earth, but not as large as Neptune. It is the first multi-planet system discovered by crowdsourcing. The research appears in Astronomical Journal. The K2138 system is interesting to scientists beyond the fact that it was found by people sitting on their couches at home. As Rinkin reports, the planets orbit in what is called a resonance chain. In this situation, each planet takes about 50% longer to orbit than the next closest planet to the star. In our own solar system, Jupiter's moons Ganymede, Europa and Io orbit in a resonance chain. The 7 Earth-like TRAPPIST-1 planets discovered last year also likely orbit in a nearly resonant chain. The pattern of that resonance chain tells researchers that there may be other planets orbiting K2138, since the purported 6th planet seems to skip 2 links in the chain. If you keep going with the resonance chain, you skip 19 days, you skip 27 days, and you end up at about 43 days. Jesse Christensen of Caltech, one of the developers of the project, tells Rinkin. That's a really tantalizing clue that we may be missing more planets in this system. If this chain continues, there's a gap. If the results hold, the resonance also gives some hints to the way planetary systems form. According to the press release, some theories suggest that planetary systems form from a chaotic scattering of rock and gas. But a nice, tightly packed, orderly system like K2138 hints that this isn't the case. Solar system formation may be a slightly more orderly process. Like this article. Sign up for our newsletter.